Let's look at the next example problem. This is a USACO problem called the cities and the states. So we are given n cities. Each one has a name and a two-letter state code. And we say that city A and city B are related if the first two letters of A's name is the same as B's state code, and vice versa. So the first two letters of B's name must also be A's state code. In addition, A and B must be from different states. So for example, this is a pair of two cities that are related. So Flint, Michigan. So Flint, the first two letters are FL, and this is turns out to be the state code of Miami, Florida. And the state code of this, it turns out to be MI, turns out to be the first two letters of the city name. So then this is a pair of related city. The question asks to output the number of pairs of cities that are related. And N is fairly big, so number of cities is 200,000. So I encourage you to pause the video. In fact, actually try to solve the problem on USACO if you have the time. Let's first think about how do we solve it, maybe not efficiently, but at least figure out a way to solve it. So, well, that doesn't seem to be very hard. So we can loop over all pairs of cities, and then we can compare their names to check whether they are satisfy the condition. So this will be a quadratic algorithm. It will not be efficient enough if n can be 200,000. So how do we make that efficient? So then, in order to make that efficient, we have to avoid doing something for every pair of cities. So then that means if we look at one city, we don't want to go through all the other cities to figure out whether that pair is related or not. Instead, we want to, given one city, we want to quickly look up all the cities that are related, or at least could be related to the current city. So now how do we do that? So the question is, for each city, can we quickly find out which cities are related to it? So can we use a data structure to help us, essentially building kind of like some kind of indices, so that we can quickly find the things that we are interested in. So let's look again, let's think concrete. So given the city name Flint, Michigan, what feature must the city name have in order to, or has to be related to this city? So that city name must start with MI. It must be MI something followed by FL. The state must be FL in order for it to be related. So can we quickly find those cities? So the answer is yes. We can build an index using this as the key. So essentially, by here, index essentially means a map. So we can use the first two letters of the city name concatenated with the state code. This four-letter string can be used as the key, and then each city will be added into, or at least we will count how many cities will have this key value using the map. And then when we see Flint, Michigan, we know that in order to find a related city, we have to take the state code and then use the first two letters of this, and then we look for that in the map. So then in order to add this city to the map so that another city can find to be related to this one, we need to add this city under the key of state followed by the two letter of the city name. So essentially, the key idea here is that every city will have two keys. So by one of them, for example, for Flint, Michigan, one key is MIFL, the other is FLMI. So we use one of the keys to put it in the map, and then we will, in order to find whether how many other cities are related with this Flint, Michigan, we will search the map using this reverse order key. So then we'll be able to find Miami, Florida, because they will be put under the corresponding key. So we also need to deal with the case that the cities must be from different states. So then that means if we have a city name start with the same two letter as the state code, then we should not consider that. Because any city that find to be related will be actually from the same state. So yeah, so this is just repeating this key idea is one value have two keys, and it will put into the data structure on the one key, and then when we do lookup, we use the other key. And this idea is actually fairly common in solving many problems. So here's the code in Java. It's actually quite short. So after reading in the data, the key data structure is this map, which map is string to an integer, counting how many times that string occurs. So we read in the string, and then we take the first two letters. So that's the city code, and then we read in the state code. So if city code equals state code, we will not do anything. Otherwise, we construct the two key. Yeah, I guess this is not, so actually we can directly put the city plus st here in place of key 1 and st plus city here. So basically we do two things. One is we look for matches, and then the other thing is we add this to the map. You may have noticed that the more natural way is first time you go through all the cities, you add it, and then second time you go through all the cities, you look. That way every pair will be counted twice. Every pair of related city of A and B will count it twice, because when you look for which cities are related to A, you will find B, so that will add 1 to the count. When you look for which city are related to B, you will find A. So here, what we are doing is we add the city as they come, and then for each city, we will look from the cities we have already seen, is there a related one? So when we do it this way, every pair will be counted only once. And we actually don't need to store all the city names while we go. So here is essentially the same logic in C++. So we use a map string to int. I guess the only thing I want to illustrate is you can use this array reference syntax in C++ for map. So this will give you the value corresponding with this key in the map. And if the map is not, if no value is assigned, so the default value will be used. And in the case of integer, the default value will be 0. So this does exactly what we wanted to do. So when we do this lookup, if the key does not exist, this will just give us a value of 0. Yeah, I believe what happens is actually they will create this mapping for this string if it doesn't already exist, and then they will put a 0 as the initial value. So similarly, we use that. We don't need to check whether it exists or not. We will simply increment that value. If the key did not already exist, then a new one will be added and then start with 0. So this will just turn that 0 into 1. So this also illustrates the similarity between map and array. So array is just the map, the sort of there's implicit indices map to value, and a map just makes the key explicit.